any device, any possible feasible device that could run, and mostly vintage devices. I can even cover non-vintage devices, but the scope of the project is about 8-bit vintage computers, consoles, arcade boards, and so on. So to give you an idea of what it is, I can compare it to other projects that do something similar. But still, I think that Crosslib is unique. Many other projects are unique, but in that I do things in a different way, and I have a different goals. Similar looking projects are 8-bit Unity. I think some of you know about 8-bit Unity, which is a super cool project, which is a library that supports at least, I think, 5 different targets to code in C, in the C language, games. You can code games, and it has lots of features. And but it's only most 6502 based, so it depends on CC65. There are other dev kits that do something somehow similar, like Turbo Rascal Syntax Error, which is Pascal based. It's a dev kit, and Turbo Rascal is different in that it supports more targets, and but it's using the Pascal language, not the C language, and it has its own compiler. So Turbo Rascal is much more than just a library. Crosslib is only a library. It's not a compiler. I depend on compilers. I depend on many compilers. Actually, I use a dozen different cross compilers. And I cover up to 200 different systems. I cover any, well, not any, but many exotic devices. And of course, I don't support all the super special effects you can do with the other tools. So I only support minimal graphics and sounds, but still you can write games. I can show you some of the games I've written with my library. So this is just a table that shows some of the differences and some of the limits of the different dev kits. So the idea is that of Crosslib is that you write your game code once, only once. You never modify it again, and you compile it for 200 different systems. So you write only one game once, and you get 200 versions without modifying, without even adapting the code. Crosslib is supposed to produce 200 different versions of your game, even adapting to the different screen size, to different colors, to different features. It will produce the same game with the same sort of sounds, the same graphics, automatically. You get 200 versions for free. You write it once, you get 200 versions for free. How is this possible? Well, this is possible because the C language is a standard language, so all the logic can be done in C, and the C language is the same across all the cross compilers that are NCC compatible. So that part is done by the C cross compiler, not by me. I get this for free. The problem is that input output, sound, graphics, keyboard input, joystick input is different. There is no standard C library for that. So I had to implement this for 200 different systems. And so you basically, and I exposed this in an abstract way. So I have done the work for you. You use my universal APIs, And you get a game that uses the joystick, the keyboard, and the sound capabilities of each system in a way which is somehow abstract. This is a little advertisement I'm doing on a related project. I have documented some of the tricks I use in C when I'm coding for 8-bit systems, computers and consoles, and I have put this on GitHub. Because when you try to code in C, even if you're not using Crosslib, this is independent of Crosslib. Of course, you cannot code in C as you would do on a real modern PC. You have to do some tricks, and I use many of these tricks in Crosslib, and I've collected some of these tips and tricks on my GitHub page. So if any of you is interested in this, you can take a look at this. As I have mentioned, so Crosslib is a library. You write your code with C and Crosslib, and you compile it with the dozen different cross compilers. It will always compile and produce the same game. So I have to support many cross compilers. So this is a partial list of the cross compilers I'm supporting. Of course, C65 to cover all MOS 6502 architectures. So all the 8-bit Commodores are supported by C65. For the Zilog 80, I'm using the Z8080DK dev kit, which has 2 different cross compilers. I support both of them. I use this also for the Commodore 128, because I can even produce a version of my games that run on the Commodore 128 in Zilog 80 mode. Not CPM, it's mode 128, but in Zilog 80 mode. So I'm using the Zilog CPU if I want to, and I can do this exotic thing. I use CMOC for the Motorola 6809 architectures. I use LCC 1802 for some exotic computers and boards, like the 1802 boards that I use on on the Voyager. So on some of the, so I could run my games in space. So some of these CPUs are used were used by the NASA. And I support ACK for some other vintage, including vintage systems, like including the PDP, for instance. I support a XTC68 for the Sinclair QL, and lots of different GCC modded cross compilers that are based on GCC, but have been modded to support vintage CPUs to cover many other systems. So as I mentioned, the list of targets that I support is very long, so I won't read these slides. These slides are only meant to impress you. So it's a long list. It's only a partial list. So, and there is very well-known computers like Apple II, for instance, all the Commodore 8-bits, all of them. And exotic stuff like the Comics 35 that is based on the 1802 CPU, the Coco computers, and Commodore 128 in different flavors, and lots of stuff, which I won't read here. And all sort of Eastern European computers that were only used there. I support lots of consoles, handheld consoles, scientific calculator like the Texas scientific calculators as well, and some more modern stuff. So I have some initial work for 16-bit architecture like the Atari ST, Sinclair QL, Amiga, and as well as native PC. I can compile my game on a, they would run on the PC natively. This is an example of a piece of code that would run on all the systems. You just write this. Well, there is some initialization which I'm not showing here. You run it through Crosslib. Crosslib will invoke a dozen different cross compilers, and you get 200 versions of this demo, which is the Matrix Rain from the movie The Matrix. Which is using I'm reusing some of the tiles, some of the sprites I use in some of the games. So it will just look like the Matrix Rain. And this is, I think, here I'm showing the Atari 8-bit version. And this code looks like C, as you can see. There are some commands that have the _XL_ prefix. Those are Crosslib commands. All the rest is standard ANSI C. So you just that's the point of the Crosslib. You write it once, and you build it through Crosslib, and you get it for all of them. So how is this magic done? As I said, I had to do the hard work myself. I had to code the input and output for hundreds of different systems. So I have not done it really for 200 systems because some of the systems are similar. So I am not redoing the same thing multiple times, but I've done it many times. Okay, in order to cover all these systems, including very exotic ones. Then I am hiding this through some abstractions, some APIs. And I'm using macros, C macros, to do this sort of magic. So you use the macros, then the cross compiler will do some of the substitution, so that the compiler, well, in the end, the compiler only compiles the specific code for the specific machine. And for the graphics assets, for the graphics data, since these graphics data have to be passed to the linker in a way that they will be stored in specific memory location. This is not just C code. I had to do some meta programming. So some Python scripts will convert the data, the sprites, so to say, the tiles, in a way that they are adapted on the fly automatically to each system. So it looks like a little bit like this. You have some standard C APIs. So some C functions like the ones with the _XL_, which I showed before. The macros will do the magic to substitute them at the preprocessor level into, for instance, Commodore 64 code, C code, or ORIC, for instance, or Nintendo NES code. This is done by the preprocessor or by my makefile. They will just select different files. So this magic is done by either the preprocessor or the makefile that I use. And for the graphic assets, because graphics have to be, I only write it once. So I only define my sprites once, and then they have to be converted into something that the specific cross compiler for the specific target has to understand and has to put in the right memory location, for instance. And this is done by some Python scripts that I run when I do a build. So all of this is done automatically. So for you just run the build, and all of this adaptation is done magically. And so you get the same game on a Commodore 64, on an Ori computer, or on the Nintendo NES game console. Of course, Crosslib has some limits. It's not meant to do super special effects. You won't use it to do games like PicQuest. You cannot do it in Crosslib. Crosslib is not meant to do super graphics and to exploit all the features of a specific system. It's not the common denominator. It's not the minimum common, because it's doing more than this, because Crosslib supports even systems that have no colors or no graphics at all. If there is no graphics, Crosslib will use ASCII characters. So the game will run even on a Commodore PET, for instance. The graphics I support, the Crosslib supports, is only tile based. It's not real sprites. But tiles can be used to do softer sprites. So actually I can do softer sprites. And sounds is very limited at the moment. But the advantage of Crosslib is that if you have a nice, simple game concept, the game concept can be even complex, but the graphics won't be very complex. You can do it in a way that it's massively multi-target. In the end, once you have written your game, you can just compile it for a given system with a command like this: make name of the target, name of the game. Something like this will compile the chase game, which is one of my games, for the Commodore 64. Something similar for a different game for the Oric. For the Nintendo NES, you can compile a different game, for instance, like this, and so on. For the Texas Instrument calculator, scientific calculator, you can do it like this. So once you have written your game, the build is trivial. How much time left do I have? I think I have enough time to present some of the games.
Well, we have a bit past, but of course you inherited a bit the delay from before.
I just want to, I don't have too much to say, but I want to present at least one of the games.
If you have one, yes, please do. Antonio is next. If you have any issue with the time, Antonio, please shout. But otherwise, okay. I would say let us focus on this topic now, please, Fabrizio.
No problem. Go ahead.
So I've written a few simple games with Crosslib, massively multi-target. I will go through these slides very quickly because I want to show you one game. Cross Chase is the game that is probably the record holder for the number of ports. It's a game that runs on about 200 different systems. It is sort of it's not a clone because I was not copying the concept. It's similar to GNOME Robots, which is a game you find with Linux, and it's a strategy game. In Cross Chase is an action, real-time version of that game with some other concepts. Cross Shoot is a different game, but it's a sort of a Robotron clone. Cross Bomber is interesting for it's a horrible concept. It's not my concept. It's a horrible concept because it's about a fighter, a bomber plane who has to destroy buildings. You have to destroy the town. It's a game that was first written for the Commodore PET, and it had a different name. It was called Air Attack. And it was also ported to different Commodore machines in the 80s under a different name. It was called Blitz. For the Commodore VIC-20, for instance, there is a game called Blitz. This is a clone of that game. And then my latest game is Cross Snake, which is my personal reinterpretation of the Snake game and the Nibbler game. So it's about a snake eating stuff, eating apples. So this is what Cross-Snake looks like on different systems. On the Commodore VIC-20 here, this is the MSX1. This is what it looks like. This is what it looks like on a Game Boy. I repeat again, this is the same code. You just compile it, you get the same game on all of these systems with different colors, different screen size, and it's done for free automatically by Crosslib Magic. This is a short video of the first level of on a Commodore VIC-20. The concept of the game is different than Nibbler and Snake. What it shares with Nibbler, the fact that walls do not kill you. So you have to eat apples in order to complete the level. You can also eat other stuff like the rings, the white rings, to get special powers if you collect enough rings. In order not to die, you don't have to starve. 20 here is your energy. If you do not eat apples too quickly, you will lose energy, and the snake will move faster till you die. You have to, so you die if you hit yourself, as in the old Snake games. You die if your head hits the mines that are moving, and you die if you starve. So by starvation, by hitting yourself, or by hitting with your head the mines. These are the first levels, so they look very easy. But then it gets harder. There will be many mines. There will be up to 6 mines, and there will be more apples to collect. There are many items. There are about 50 secrets to discover in this game, which I don't show in this video. And on this level, you only see the rings and the apples, but there are items that are enabled if you get at least three rings. So you can get special powers. You can freeze the mines and so on. And okay, I have the other games. This is that I can say a few words about them. Cross Chase is the one that is probably ported to the highest number of systems. This is the game on Linux, not my game. This is the original robots game, and this is my version on the Commodore VIC-20, and it also runs on a scientific calculator, as you can see here on the Texas Instrument TI-83, but it also runs on other calculators and some on exotic devices. And I can complete my talk here. That's all. There are other games that have different concepts, and all of them share this idea that you write the code once and you build it for all of them automatically.
I've been playing actually your
and this is the Commodore PET version, the original Air Attack Blitz clone on the Commodore VIC-20, and my version on the Commodore VIC-20. My version actually is using soft sprites, so not just characters. That's all.
Thanks a lot, Fabrizio. I was just saying, I have played, I think once you had put on one of the Facebook groups, you had posted a link to a playable. We could play more or less online, these cross, the Snake. Huh?
Yeah,
it was good fun.
You can play my games online as well on different systems.
Maybe you can put the links after, you know, in the chat.
All these links are on my Git. If you just go to my the GitHub page, I have put links for all the 4 games on up to 6 or 7 different computers, including Commodore 64 and the Commodore 264 series as well, and some other systems like MSX and some exotic systems as well. They can be run through some emulators that run on JavaScript.
And I see that in the background, Martin continues to answer a question, and also he has just posted the link to your GitHub. So thanks, Martin, for that. Let's go maybe very quickly over a couple of questions that I see here about the graphics. How are graphics assets represented on text-only platforms such as CBM 610 with 610?
For text-only systems, the graphics assets you have to decide. So you have a set of tiles. Tiles are either graphics or mapped to an ASCII character. So, and you can do it per target. Usually, if you really want to, you can just say on this target, I want tile number 1 to be shown as a $sign, for instance. Or if graphics is enabled on that target, the tile 1 will use the shared graphics. So for tile 1, I have a file where I define what the tile 1 should look like. This is my assets. This is not a C file. This is a data file. When I run the build, a Python script will take the graphics file and convert it into something that the linker can understand. If the system has no graphics, the tile will be interpreted as an ASCII character. On a given game, I decided that tile 1 can be, I can do two things. I can either say tile 1 is mapped to the $sign, or I can say tile 1 is mapped on a specific system to a different character. Of course, if you do this, you might have in your code, you might have to have two versions. You might have to have an if a game is using, for instance, softer sprites, you might have to have a version of the game that is using softer sprites and a version that is doing something different when there is no softer sprite. Unless if you really want to use softer sprites and you still want to have the same game running on a system that has no graphics, you might have a nice animation instead of a softer sprite, of a smooth sprite, or you might have to do something in the code.
Yeah, for some reason I had unmuted myself. Thanks, Fabrizio. I think looking at the time, I see there's a couple of other questions, but maybe you can also just answer them in the chat. Thanks a lot.
Okay.
And you killed actually my transition, because you said already you will not be able to develop a game like Pig Quest. I was going to use that as a kind of transition to Antonio. Okay, so I will just now stop this recording.